Earlier in this chapter, we learned about imaginary numbers, and we learned that I is equal to the square root of -1. So now in this part of the unit, we are going to be simplifying I more than we had before. We started off by saying that anytime you saw an I squared, that was really equal to -1, because we know that when you square I, we are squaring this square root. And because we're squaring the square root, I squared is equal to what is underneath the radical. So I squared is equal to -1. Okay, so that's one piece of information for this. The other is what happens when we have I cubed. Well, it's showing you right here, but let's just go through that. So I cubed is equal to I times I times I. Okay, and when we multiply these two i's together, that is I squared, which we know is -1 from right over here. And then I, we can't simplify that, so it's equal to I. So I cubed simplified is equal to -I. So this, along with I squared equals -1, is what you are going to be using to solve these problems right here. And what I want you to think of as you work through simplifying these 6 problems is there a hypothesis that you can derive or that you can work through while figuring out what these 6 problems are? So right now all you're using is that I squared is equal to -1 and I cubed is equal to -I. So as you work through these problems, I want you to think of what your hypothesis will be, and then answer the questions that show up in Edpuzzle, and then I will be back. Okay, so now you've had a chance to work through what these 6 problems are, and let me just give you what the answers are. So I to the 4th is 1. I to the 5th is I to the 6th is -1. I to the 7th is -I to the 8th is 1. And I to the 17th is I. So I wonder what conclusion you came up with or what your hypothesis could have been as you worked through this. Okay, the pattern that we want you to notice is that anytime you see an I to the 4th, it equals 1. Okay, so if you didn't get to that, let's talk about that. So I squared times I squared, using properties of exponents, when the bases are the same, we add the exponents. That is equal to I to the 4th. So I just wrote it out as the product of the bases are the same, adding the exponents, and I get I to the 4th. Well, I know that I squared is 1. So 1 times 1 is equal to I to the 4th. So I to the 4th is equal to 1. Okay. The other thing that maybe you noticed as you worked through these is we're always looking for some grouping of I to the 4th. So let's take number 2, for example, I to the 5th. I can rewrite that as I to the 4th times I. Because the bases are the same, I add the exponents. 4 plus, if I don't see 1 here, that means it's a 1. So I'm writing it this way. And I know that I to the 4th is equal to 1. So I to the 5th is equal to 1 times I, which is I. Okay, let's try one more. Let's try the number 5, the I to the 8th. Okay, so I to the 8th, if I write that as the product of the bases with the exponents, I would have I to the 4th times I to the 4th. 4 plus 4 is 8, so I to the 4th is 1 times 1. I to the 8th is equal to 1. So that should give you some little bit of simplifying there. I'll just move my page down. Okay, so in the next problems, you are going to be simplifying these complex equations, complex expressions. Okay, so here's one that looks familiar, but you will be working on, these are the next 8 that I want you to work on. Okay, so the simplified answers on these 8 are, I to the 6th is, number 1 is -1, number 2 is -I to the 81st is I. This simplifies to -4, -4 minus 24I. Number 5 is okay. When rationalizing denominators, you want to multiply by what is called a complex conjugate. So when you multiply by the conjugate, we are looking at the denominator, and we are going to multiply the denominator by the same terms in the binomial, but the opposite sign. And what you do to the denominator, you must do to the numerator. So let me work through this example. So we're going to multiply this whole fraction is going to get multiplied by 1 plus 2I over 1 plus 2I. Okay, so these are binomials, so I need to have parentheses around them. So when I multiply these out, in the numerator, we'll have 2 times 1 plus 2I. And in the denominator, it's the difference of 2 squares. So the middle terms will drop out. We're left with, we FOIL this, the middle terms will drop out because we have a -2I and a plus 2I. So those two cancel out. So what I'm left with is 1 squared, which is 1, minus 4I squared. Okay. So as I keep multiplying, I have 2 plus 4I over 1 plus 4. Because remember that I squared is a -1, so I have 1 plus 4. So my simplified answer is 2 plus 4I over 5. That's my answer. Okay. All right, so let's look at this one. It's a little bit different because I have the subtraction in the numerator. The problem is not with the I in the numerator. The problem really is with the I in the denominator. So what I need to do is just multiply by what is in the denominator. So I multiply by I over I, which equals 4I plus 9 over negative 12. Where did I get all of that from? Well, 4 times I is 4I. The negative 9I times I that would be minus a negative 9, which turns into a plus 9. And then it's divided by the I squared, which is a negative 12. Okay, so your answer would be okay like this. It would be better, I think, to have a to get rid of the negative in the denominator. So the better answer would be negative 9 minus 4I over 12. But really, either one of these works. As long as the 12 is in the denominator, you don't have I in the denominator, either one of those works. Okay, all right, so now it is your turn to try. Okay, the answers to the problems that you just worked through. Number 1,